Hello, everyone, guys. Thank you for coming to this opening webinar for the Axiom Programming School. And thank you for your interest in programming in general, in learning how to program. And thank you for picking Axiom as the place to do that. So I would like to start this webinar with a little introduction. So a few words about myself, about the school, and about what to expect from the seminar. So first of all, a few words about myself. My name is Anatoly, and I have been working in the software domain for the past 9 years. And those have been various things, such as machine learning, such as backend development. And currently I'm working with the core team of the Scala programming language to help them develop this language in Switzerland, in the university called EPFL, which is a polytechnic university in the Swiss city Lausanne. A few words about my background. Originally, I come from Ukraine. I do not have any formal computer science training. I have a degree in law. I started doing programming back in the university days as a hobby, which later became my primary occupation. After the university, I started doing programming as profession, as a freelancer. And my primary language of choice has been Scala ever since, for the reasons I'll get into a little bit later into this introduction. And 3 years ago, I came to EPFL, to the university that develops the programming language called Scala. And there I was mostly doing as language development, but also mentoring of students and helping them grasp the programming concepts better. And that is how I came to the teaching business. And this is how I came to the idea of creating a school for complete beginners to help them acquire the programming knowledge. Because in the past, I was once a beginner without any formal training in computer science. And I didn't have anyone to mentor me. I didn't have any resources to study programming by. And so I had to do everything by myself. And it is a little bit slower than if you have some guidance. So that was a little introduction about myself and my background. And next, I would like to say a few words about this school and what to expect from it. So first of all, the primary focus of the Axiom School is the complete newcomers. So people who have no prior exposure to programming, no prior exposure to computer science domain. So people who not necessarily know how to get started. And hence, if you already have some computer science training, some programming background, then the concepts that I propose in my book and in those webinars might seem a little bit familiar to you, which is also fine if you find some insights in those materials. Since those materials and webinars are aimed on the complete newcomers, there is a specific approach that I'm taking to teach. And this approach is concepts first and not programming languages first. So what does that mean? So very frequently, when people come to the programming domain, they question themselves, what programming language should I study? And very frequently, the answer is Python, because, well, Python is perceived as a simple language and has a low entry barrier. However, very frequently, people struggle also with Python. And why is that? Well, the most frequent case that I discovered when working with people who are just at the beginning of their programming journey is the main problem is not even the programming language concepts themselves, but the so-called surrounding concepts. So what does that mean? So it means which software do I need to download to write Python in, to write Scala in, or to write Ruby in, or whichever language you want to write. Then the question is, what all those buttons in this software do? Then the question is, what if the error happens? And the computer starts telling you something, that an error happened on this line, and how do we understand that? How do you work with that? So all of those are concepts that are not necessarily programming language concepts, that are but that are necessary for you to know to be able to advance in your programming. And if you do not know that, chances are that you would get stuck on one simple thing, on the very basic program, for a couple of weeks. So this is why I'm taking the concepts first approach. It means I'm not aiming to teach a programming language specifically, but the concepts that are necessary for you to know as a programmer. I picked Scala as a programming language of choice. Why Scala? Well, because for teaching purposes, it is a language that incorporates a lot of concepts. And the idea is that if you know a concept in one programming language, it is very easy to switch to another programming language. So a little example, a concept of a variable, for example. If you have tried studying programming, then you must have encountered the concept of a variable. If you do not know what it is, no big deal. There is a concept of a variable in programming, and it is in virtually every programming languages, it is present. So the idea is that when you learn a variable first, you might spend the most of the time to understand why do we need variables at all, and in which situations we might use the variables, and what kind of programs are possible to construct using variables. And writing a variable in any programming language is fairly simple. It's usually a name of a variable, an equals sign, and the things that this variable equals to. So it's not a big deal to learn how to write things. It's a big deal to understand what things do. And so if you understand how things do in Scala, you can come in any programming language of your choice, and all you need to learn is how to write those things. And this is very easily acquired. So Scala incorporates a lot of concepts. So if you know Scala, then it's very easy to switch to any other programming language that you might need to use. Regarding the logistics of how the learning here is structured, well, the main learning resource is the book that I'm writing as we do this Axiom School together. It is linked in the Discord channel. And this book, it aims to cover the fundamental concepts of programming, using Scala as an example, in a beginner-friendly manner. During those seminars that you are currently on, we are going to be covering the concepts from the book and also answering your questions. So speaking about the seminars and their structure, well, what I have in mind currently is that for the first 20 minutes or so, we are going to be covering first chapter of the book or the next chapter of the book. And for the subsequent 30 minutes, we are going to be answering questions. So during the first 20 minutes, when we are covering a concept from the book, you can ask your questions if something is unclear using chat. I will be looking at the chat periodically. And during the questions and answers session, you have the possibility to raise your hand using the Zoom feature that I mentioned on Discord. In the announcement for the webinar, I mentioned how to raise your hand on Zoom. And then you will be unmuted and you'll be able to ask the question. One remark about the questions, so please keep them to the point of the of the webinar, to the topic of the webinar, and to the topic of the course, so that the content is useful for everyone. So just to give you some examples, so maybe it's not a good idea to ask questions like, what is the best language for machine learning? Or which bootcamp should I enter to study robotics? Those are good questions, but please keep them to Discord. There are channels on Discord that you can ask them on. But if something is unclear about the webinar or about the topics that is being presented, then please feel free to raise your hand and ask the question. So that was a little introduction from me. If you have any questions, please feel free to write them in the chat. So far, I do not see any questions in the chat. So I think we can move slowly to the first topic of the book that we'll be discussing today. And the topic is called The Data and Logic. It is the first chapter of the book. So first of all, let me share my screen so that you see the whiteboard. Is my screen visible to you? Okay, so I see Olga says yes. So we can start with the first chapter of the book called Data and Logic. When reading this chapter, you might have noticed that there is no actual programming in there. So we haven't written any single line of code in this chapter. So what we are going to discuss in this chapter is the foundations of the worldview to take when dealing with programming. As I mentioned before, we are focusing on the concepts more than on the actual way to write software in any particular programming language. So before we actually start learning any particular writing any particular code, it is important to understand how people look at programming, how computers look at programming, and how software systems work. So speaking about the software systems, they can be viewed in terms of just two things. So data and logic. So literally any software system, any website, any social network, any mobile application, anything at all that is in the programming, that is a program, can be viewed in terms of just two things, data and logic. Consider, for example, a social network, such as Facebook. So you log into a social network, and the first thing that you might see is a page. And on that page, you'll have your profile picture. You might have a background image. Let's assume there is a sun on that background image, a mountain. Also, what is usually found on a Facebook page is user information. So you might have information about where you live, where you went to school, where you work, and so on. Besides that information, what else is found is a feed, and the feed consists of individual posts. So every post is this little box, and for every post, what does every post consist of? Well, it is a picture of a person who posted it, the name, for instance, Anne, and some text. So that's your typical Facebook page. Now, the thing is that everything that you see on this page is data. So data is information that is stored in the computer. And in our case, the information is about the person, a person's profile, and the information in question is what we have just described. So what data can we see on this picture? Well, first remark that needs to be made is that data is can be of different types. So here we can see, for instance, the profile picture would be of a type picture. We can say that this picture. Also, the background image, it is also a picture. So we can say picture. The status of the person and the blog posts and the feed posts that the person has on their feed, they can be seen as consisting of text and pictures. So this would be the picture, and the username and the content that they wrote on the feed would be the text. Now it is you need to understand that the data is organized by data types to model very closely how we people think of data. So, for instance, if for us as a user, it is normal to discuss, for example, the feed of a person with all the posts, then chances are that for the programmers that codes the Facebook web page, it will also be natural to talk about the web page in terms of the feed that consists of posts, and individual posts, they consist of pictures, profile pictures, and the text. So one important thing to realize about the data is that it is made, well, it can be of different data types. And another thing that you might have noticed is that one data type is made of other data types. So, for example, the profile user profile itself is made out of the pictures for the profile picture, for the background of the feed with all the posts, with the status information. So all of those data combined, they comprise a single data type of a profile, of a user profile. So and so on. Next, the logical question that arises is what is the fundamental data type out of which everything is made? Well, it turns out that there is such a fundamental data type out of which all of the data types are made, and it is a number. So let us see how you can represent different things using the data type of a number. So let's start with text. So on our Facebook example, we see that there are posts, and one of the data types that make up the post is text. So say we have the text of saying cat. how do we represent it with a number? Well, one way to represent a text with a number is to assign a number to each letter. So for instance, we agree that if we write 0, this means letter A. If you write 1, it means letter B. 2 is C, and so on and so forth, until we get to the very last letter, which is 26, if I'm not mistaken, which is letter Z. And given this encoding, like having a number corresponding to a letter, we can represent the word cat with three numbers, which will be 0. If I'm not mistaken, it will be 2, 0, and 19. So that's the way you can represent a text with a number. And what does that mean? That means that if you are talking about a Facebook post, it consists of a username, for example, Anne, and Anne wrote cat. So it means we have the means to represent the username, the Anne, with numbers, and the word cat also with numbers. So it means we can represent the entire post using numbers. We can make up the entire Facebook post using numbers. So what about the pictures? Well, you might know that a picture, for instance, let's say it is a picture of a mountain. It is made out of pixels. So probably have all heard of pixels, and you have all heard a term like when, for example, watching a YouTube video, it has different quality settings. So those quality settings, like for 80p or 144,000p, so they all correspond to the number of pixels in the image, and therefore, as the higher the number of pixels, the higher the quality of an image. So how does that exactly work with pixels? So every image has its dimensions, and the dimensions are expressed using the numbers of pixels on each side of the square that makes up the image. So for instance, if we have 1,000 by 1,000 image, it means that there is 1,000 of pixels on the width and 1,000 pixels on the height of the image. And what it means is that an image is a grid. So I'm drawing a grid of pixels. There are many more of those pixels because it is 1,000 by 1,000, but here we have a rough approximation. And the idea of how an image is built is that some pixels have certain color. Like for instance, if we have an image of a mountain, we will have the top of the mountain colored as white to represent snow. So this will be white color. This will also be white color. And the rest of the mountain, let's say it is a green mountain. So all of the pixels below the white cap, they will be colored green. So since an image is made out of pixels, this means that when we can represent a pixel in the computer's memory as a separate data, then we can easily represent an entire image using those pixels, because we can just say, okay, we can represent a single pixel, and an image is just many pixels. So the question about representing an image in the computer's memory, it boils down to the question of representing a pixel. So what is a pixel? Well, a pixel is a colored square. It is a little dot on the screen that has a color. The idea is that pixel is defined by its color. So we can say that if we can represent colors in the computer memory, then we can represent pixels in the computer memory, and then we can represent images. But there are a lot of colors. So how do we represent a color with a number? Well, you might have heard previously about the so-called red, green, blue encoding. And the idea is that it is possible to come up with any color if you blend the colors red, green, and blue together. So every color has a red component, blue component. Oh, sorry, let's write the green component first. And finally, the blue component. And for example, if the red component is at 100% and the rest are at 0%, it means that the resultant color is red. If we have all of those components set to 30%, for example, the resultant color will be gray. So can anyone tell me in the chat what would be the color if we have all of those components, red, green, and blue, set to 100%? So I'll give you a little time. So I see the answer is black. Any other options? Well, in reality, the colors that you get is the opposite of black. It is white. The idea is that if you set the, think about physics, for example, white is a presence of all colors at all. Like if you look at the sun, for example, it appears white with a little bit yellow hue. But the idea is that if you have all of the colors present at their full intensity, the blend is perceived by us as white. And by contrast, if we have absence of every component of all the colors, what would the resultant color be then if you do not have any component at all? Yep. Once, if you do not have any color at all represented, then the answer will be black. Now let's have a look at what we have just done. We have managed to express every color. We have found a scheme to represent every color using 3 percentage numbers. So we say if we have the first percentage set to 100%, the second to 0%, and the third to 0%, then he says that it is color red. And if it is all set to 30%, 30%, 30%, it means that a little bit of each color, it means gray. If you have 100% of each component of each color, this means white. And if we have 0% of all the colors, it means black. So we can just learn how to represent a color with a set of 3 numbers. This means that we have learned how to represent pixels with numbers. And if we can represent pixels with numbers, then we can represent the entire picture as a lot of pixels. Now, a question I would like to ask you is how would you represent sorry, I will not draw it because I cannot draw it very well, but how would you represent a movie using what we have just learned? So we know how to represent text, for example, how to represent numbers, how to represent pictures. How would you use those data types to represent the data type of a movie? So there is, Olga says by number, and Mehdi, am I pronouncing your name correctly? Mehdi says continue picture. Yeah, okay. So do you by any chance want to take the mic, Mehdi, and explain a little bit about what you mean by continue picture? Yeah, if you want, then you can unmute yourself and tell us how would you represent a movie using what you have just learned. If not, then no big deal. Just let us know.
Thank you for your question. For movie, normally we see a frame of pictures are continuously change. So that's why I answered we will change the frame of pictures. And every picture is actually we define by the pixel. That is the thing. But for movie, we will change the picture in a very quick way. So the continuous picture becomes the movie actually. That's what I actually. Thank you.
Yeah, thank you. So that's exactly right. So just one thing is change is already logic, and we will discuss logic a little bit later. But you're completely right that a movie can be represented via just a set of pictures, and we change pictures very quickly. So this shows you how a number is a fundamental data type. And how everything can actually be built up out of numbers. Another very special type of data that I would like to mention is something called collections. And we have actually seen them in our example several times. So for instance, on the whiteboard, I show you the Facebook feed, which consists of posts, right? So there are many entities of the same type, many posts. And when we were discussing an image, then we have noticed that an image is many pixels. And when we were discussing a movie, we have noticed that a movie is many images. So this situation, when we have many of the same data type, many entities of the same data type, is pretty ubiquitous in programming. So whichever programming language you decide to go to, whichever job you decide to have, either I don't know, a web developer or a machine learning specialist or a mobile application developer, collections will always follow you because collections are everywhere, because we rarely operate on only one entity. For instance, a database of Facebook can be represented as a collection of user profiles, many user profiles. So that's just something to keep in mind, that it is a big deal, and it is something that you will encounter in many programming languages. We are not going to go in depth about collections right now, but we are going to cover them a little bit later, and it is going to be a pretty challenging topic. But just for you to keep in mind that it is one of those challenging topics and concepts that you need to really grasp if you want to be a good programmer, because it is a big deal and it repeats everywhere. Okay, so that was the data that we have just covered. And but at the beginning of the seminar, we have mentioned that everything is programming is either data or logic. So the question is now, what exactly is logic? Well, so far we have discussed just how the data is represented. And the representation of the data can be seen as something written on a piece of paper in a book. And if something is written on a piece of paper, normally you do not expect it to change. So, but in computer systems, in programs, this is rarely the case. So somebody might come and put you a like on one of the posts. Again, sorry for my bad drawing. Somebody might come and write a new post, and thereby changing the look of your profile. So how does that exactly happen? The idea of the data is not enough to describe this kind of change. When we were discussing the idea of a movie, Mehdi has mentioned that when explaining the idea of the movie, he mentions that it is not just a lot of pictures. No, it's also the way they change, the way they are constantly represented one after another to the user with a certain frequency to make an illusion of a moving picture. So the idea of change is captured in programming via the idea of logic. I see there is a question from Mehdi, which he sent to me in the direct messages, which is, in standard practice, do the web developers use Scala? If yes, they can, then can you give a real example? So yes, Scala is used for web development and for machine learning development, but this is a little bit out of scope of this seminar, so I'm not going to go into details. If you want, you can ask this question on Discord and continue the discussion there. But talking about the logic can be, the logic basically is the act of changing the data. So the act of changing the data can be, for example, uploading a picture to Facebook, uploading a new profile picture, or it can be posting a comment, liking a post, following someone, so things like that. So basically, data and logic are those two things that you can use to view everything in programming with, and this will become handy in the subsequent chapters when we are going to learn some concrete concepts from programming, from Scala, and see, and we will see how the idea is how the ability to look at everything from the data or logic perspective will give us some sort of guiding lines, some sort of grid to be able to orient ourselves in the world of programming. So that was the first chapter of the book. And that was all that I had for the presentation. And now the floor is yours. And if you have any questions, we have 30 minutes to answer them. So if you have any questions, please raise your hand in Zoom using the raise hand feature, and you'll be given, you'll be unmuted. I'll unmute you, and you'll be able to ask your question, and then I can answer it. So please, if you have any questions, feel free to raise your hand. While we are waiting for anyone to come up with a question, maybe I can a few words about to give a little bit more elaborate answer to Maddie's question about the usages of Scala. So, and why exactly I decided to pick that language for this course. So, Scala is has a big usage in machine learning and data engineering domain. So, data domain, it is divided into two parts, basically, two big areas. It is data science and data engineering. And in data science part, you figure out what works, a model that works. And in data engineering part, you figure out how to make that thing work for massive amounts of data. So in the first part, the part about data science, figuring out what works, Python shines. Python is the dominant language, but Python is slow. So if you want scale, then Scala there is a pretty dominant language and leader. So many companies, they switch to Scala just because they need machine learning and machine learning at scale. And this makes Scala one of the leading languages, one of the highest paying languages in the world. Otherwise, Scala is used everywhere where it is there is a need to process massive amounts of data. So since like highly loaded systems, Twitter was using Scala at some point, Netflix uses Scala currently. Disney is also using Scala. So all of those big companies, not all of them, but many of them, pick Scala as a language of choice. Banks, some banks, they use Scala in Europe, for example, Morgan Stanley, just because Scala is so good in dealing with massive amounts of data. And but I picked Scala not because of that as my language of choice, but because it incorporates a lot of concepts. And if you know those concepts, it's a challenge for, first of all, it's a challenge for you that allows you to grow. And second, if you know those concepts, you can express more complicated programs more easily. You're less likely to get lost. And you're more likely to advance more efficiently when exposed to many challenging concepts. So another question from Maddie, I see in the chat, is how can data be expressed in a programming language or Scala? Well, that's what we have covered in this session. So the trick is numbers. The idea is that all of the data is built up of some other data, and the fundamental data type from which everything is built is a number. So the idea is that if you can represent a number, if you can express a number in a language, say Scala, then you can express all of the data that you want to express in that language. Now, the numbers actually are not the end of the story, because the computers actually understand under the hood only two numbers, which is 0 and 1. And out of that, they build up all the other numbers. But that's not necessary to know as a beginner. It's useful to keep in mind, but not necessary to know. When you hit it, you will know that you need it. And the ways you can express data in the programming languages is the topic of the next seminar, of the next chapter of the book, and basically it boils down to variables, so-called object-oriented programming, with all its framework to basically be able to say that, to explain to the computer what a pixel is or what a picture is. And in case of variables, it is what's the name of a data. So variables are for giving names to pieces of data. But we are going to cover those in the future seminars. So which types of numbers are there in Scala? Olga asks. So in Scala, there are a couple of fundamental data types. And speaking about numbers, there is an integer, three floating point data types, which is float, double, and short. And basically, they all differ by how big of numbers they can represent. Usually, we work with doubles. And also, Scala can understand a bunch of other data types out of the box, which is Boolean, which is basically yes or no. We will learn it a little bit later what the role it plays in programming, but it is yes or no data type. It has two values, and text, which is a string, so-called string data type. Yep, and another data type that Scala has is called byte, which is for smaller numbers. But usually you do not need to worry about many of them. Usually you use int for whole numbers like 1, 2, 3. You use double for fractional numbers like 1.5 or 3.6. You use Boolean very frequently for yes or no, and that is used frequently to tell the program which path to take. Like for instance, if the weather is good today, then take an umbrella. Otherwise, take something else. So it's a branch in data type. It's used in those areas. And if you're talking about string, this text, for instance, cat. So those 4 data types is basically what you're using on daily basis as a Scala programmer. The rest of them are less frequent. So I don't know if there are any more questions, then please write them in chat or raise the hand to ask them using the mic. And if there are no more questions, then I think we can wrap this up. So as a closure, I would like to thank you again for coming to this seminar and for the interest in learning in our programming school. And as a final note, as a final thought, I would like to mention that to master programming, it's important to stay consistent. So practice something every day, study every day to improve your skills. But also it is important to have communication. We have this big Discord server, or not that big so far, but we have the Discord server where we can stay in touch with one another and ask questions. So if you have any questions or if you would like to discuss anything, you can always go there. And final thing is feedback. So as I have already mentioned, I'm only writing this book and I'm only starting this school and only trying out this webinar format. And this is the first webinar. So there are bound to be mistakes. And chances are that if you are studying via the books that I'm writing and you do not understand anything, or you don't understand something, or it's hard for you, or you feel like something doesn't make sense, chances are that it is my mistake and the content needs improvement. So please, I cannot stress this enough. Please give me feedback about your learning. So if anything at all you would like to discuss, please do that, because this is the only way the content and the school can improve. Another thing is outlook for the next seminar. Next week I'll be on vacation, but I'm planning to resume those seminars on a weekly basis. So let's tentatively say that the next seminar will be on September 8th, which is a Thursday in 2 weeks from now, at the same time. It will be announced also on Discord, so please follow Discord. Please use it to communicate with one another, and please give me feedback on how it goes. So that's all I had. And anyone has any remarks? Anything? Yeah, thank you everyone for coming as well. And see you next time. Have a great time of the day. Bye-bye. See you.